Welcome everyone. Welcome to this course on Basics of Logic Design. So here we are going to start this course with understanding of basic physics and the fundamentals of electricity. So let's get started. So let's understand some basic terminologies in physics, like for example, energy. What is energy? It is, as per physics, it is the capacity to do work. Correct? It's the capacity to do work. Work and energy are directly related. Only when you have energy, you will be able to do work. Whether it is a human being or it is a machine. We need to supply energy for it to do the work in the physical world. Okay? So the energy exists in form of two domains mainly. One is called as potential, other is called as kinetic. Potential is coming out of storage and kinetic is coming out of movement. Okay? For example, stored water. Water stored in dam has potential energy. This is what we studied in physics, correct? Water stored in a dam has potential energy, correct? Correct. This is movement, moving water, correct? The river is flowing. Flowing river has kinetic energy, correct? Water is flowing. The flowing river has kinetic energy. It can wash off whatever is coming on its path and take it along with it, correct? So in every in every physical element or the physical domain we are discussing, the energy exists in the form of potential as well as kinetic. For example, let's say you are cooking something. You heat the plate, correct? Whatever, let's say you are baking a bread or you are, let's say you are baking a chapati or something like that. The hot plate, whatever you are cooking, you heat it. It stores the heat, correct? Even if you switch off the stove, you go near the plate, it's hot, it's storing the heat, correct? Correct? Whereas, once there is a potential energy, so storage, wherever you are storing, the potential energy comes into picture. The energy is in the form of the potential source. It is stored. So stored water, stored heat, stored charge. You store charges in a battery, correct? In terms of electricity, if I talk, the charges are stored in a battery. Kinetic is current. Flow of charge is kinetic. So flow of charge is current, which is kinetic. So in terms of electricity, if I see potential in the, let's discuss this in various domains. Okay, let's discuss this. Okay, so if I look at the domain called, mechanical energy. Okay, mechanical energy. It's what? Water stored in a dam. Correct. Kinetic energy is water, river flow. River flowing. Correct. Water flowing in the river. Correct. In the domain of mechanical energy. If I look at the domain called heat energy. Heat stored by a body, correct? When you heat, for example, you heat your pressure cooker, correct? You switch off, let's say you switch on the gas stove, the pressure cooker stores the heat, correct? It accumulates the heat. And when you turn it off, it doesn't cool down within a fraction of a second. It cools down after, say, 15-20 minutes. Till then you go and touch the food, or the pressure cooker is hot. So the heat is stored by the body. And here it is flow of heat, correct? You go near the cooker itself, you feel it is hot, correct? From a hot body, correct? If I look at the domain called electricity, how do I store charges? Stored charges. Charges in a battery. We charge our battery, correct? That's what we say. Battery, I'm charging my mobile phone, I'm charging my laptop. That's what we say, correct? So we are accumulating the charges in the battery. And this is flow of charges, which we say current. This current is used even here. If you see, right, when the river is flowing very wildly, we say the water current of the river is very high, correct? If you see, let's say some river after a very heavy rain, monsoon season or something like that, they say that the water current in the river is very high. That means the term current is used for flowing also. Here we say water current, correct? We don't, correct? Here it is the electric current. So flow of charge is due in the electric current. So the beauty I want you to understand is, in every domain, potential to kinetic conversion keeps happening. The energy in the form of potential will always get converted to kinetic energy or vice versa. This conversion keeps happening in every domain. Correct? Like for example, let's take about the water itself. Water has to flow into the dam, correct? Let's visualize it. I have a dam. Correct? All of you might have seen a dam, right? In your life. Correct? So let's say, what is dam? Dam is nothing but what? This is the river path. They have built a big reservoir kind of thing, correct? There's a very big reservoir here. Let's say that this is the reservoir. This is my reservoir, okay? Which is nothing but a dam. Now water has to flow into the dam, correct? So water flowing in, what is this? It is kinetic energy. Now as the water flows in, water gets filled here. So water storage here is potential energy, correct? Again, when the water, when sufficient amount of water you have collected, and let's say you have collected sufficient amount of water, then we start releasing the water here for the people to use it, correct? We release the water from the dam. This is the water outflow from the dam. The moment water flow, it becomes kinetic energy. See, look at the beauty here. So the kinetic energy got converted. So if I look at the flow of activity or the sequence of activity here, we had kinetic energy of water inflow, correct? Kinetic energy of water inflow. Because if the water was not having kinetic energy, it would not be flowing. Say for example, let's say for example, if you pour a little bit of water in your table, is it flowing and becoming a river? No, right? It is not, because it is not having kinetic energy. So the kinetic energy of water inflow gets converted to potential energy of stored water. And this again gets kinetic energy of outflow water. Correct? So we are converting kinetic to potential back to kinetic. This is the play which we will happen across all the domains. Same thing is happening when you cook also. Let's say we are cooking. So this is the water example. And let's take the example of cooking.